Hey everyone, this is right triangle trigonometry today. You should remember from earlier math classes that a right triangle has a right angle in it, and right angles are 90 degrees. So this is a 90-degree angle. The other two angles are acute, which means less than 90 degrees, and for this particular angle, we consider this side opposite the angle, and this side is adjacent the angle. But the side that's across from the 90-degree angle, the right angle, that's called the hypotenuse. So in the study of right triangle trigonometry, there are 6 trig functions. They are called sine, cosine, tangent, cotangent, secant, and cosecant. And this is how we define them. The sine of my angle, which is abbreviated SIN, but we don't say sin, we say sine. The sine of my angle is the length of the side opposite over the length of the hypotenuse. So to shorten that, we would say OPP for opposite, HYP for hypotenuse. And then for the cosine of theta, we shorten the abbreviation to the first 3 letters, and we say cosine theta equals the length of the adjacent side over the length of the hypotenuse. Or we could say ADJ for adjacent over HYP for hypotenuse. Then looking at tangent, we take the first 3 letters for the abbreviation. So I have the tangent of theta equals the length of the side opposite over the length of the side adjacent. So we say opposite over adjacent. Sine, cosine, and tangent are the main 3 trig functions that we will be considering. But there are 3 more: cosecant, secant, and cotangent. So cosecant, we can't use COS, so we use CSC for cosecant, but for the other 2 we do use the first 3 letters, SEC and COT. So the cosecant is hypotenuse over opposite, secant is hypotenuse over adjacent, and cotangent is adjacent over hypotenuse. So here are our 6 trig functions, and I want to point something out. Notice that the sine is the opposite over the hypotenuse, and the cosecant is the hypotenuse over the opposite. Those are reciprocals. And then cosine is adjacent over hypotenuse, and secant is hypotenuse over adjacent. And then tangent, being opposite over adjacent, is the reciprocal of cotangent, which is adjacent over opposite. So these functions here are considered and called reciprocal trig functions because each one of these is just the reciprocal of these. So the important part is remembering which ones are reciprocals. Sine and cosecant go together, cosine and secant, and tangent and cotangent. You're just going to have to remember that. I totally forgot to put this in the video when I was making it, so I'm going to add it here. This SOHCAHTOA is a device that will help you memorize the definitions for sine, cosine, and tangent. This stands for S equals O over H, which is sine equals opposite over hypotenuse. This one is cosine equals A over H, cosine equals adjacent over hypotenuse, and TOA is T equals O over A, which stands for tangent equals opposite over adjacent. You're going to hear me reference SOHCAHTOA many times. It's not a real word, it's a kind of a made-up word, but it will help you remember the definitions of those 6 trig functions. Okay, let's see this in action. In this example, it says find the hypotenuse and then find all 6 trig values for both angles. So the first thing we need to do is use the Pythagorean theorem, which says leg squared plus leg squared equals hypotenuse squared. You may have learned it as a squared plus b squared equals c squared, but sometimes a and b and c are not the legs and the hypotenuse, so it's better to learn it this way. Leg squared plus leg squared equals hypotenuse. Now in this case, here's a leg, here's a leg. The hypotenuse is always the longest side, and it's always across from the right angle. So for this one, we have 4 squared plus 3 squared equals c squared. So 16 plus 9 equals c squared. That's 25. So I've got c squared equals 25. If I take the square root of both sides, that gives me c equals plus or minus 5, but distance is never negative, so we don't need to worry about a negative 5. I find that c equals 5. So now I know my hypotenuse is 5. Now I can take those 6 definitions that we had for sine, cosine, tangent, cosecant, secant, and cotangent, and I can use these 3 numbers. So let's do that for A. So this is my angle A, so this is the opposite side, this is the adjacent side, and this is the hypotenuse. So opposite over hypotenuse would be 3 over 5, because 3 is the side opposite and 5 is the hypotenuse. For the cosine, I want the adjacent side, which is 4 over the hypotenuse. And for the tangent, I want the opposite side over the adjacent side, so that's 3 over 4. Now for cosecant, all I need to remember is that cosecant and sine are reciprocals, so I can just take my sine and flip it. And for secant, I can take cosine and flip it. And for cotangent, I can take tangent and flip it. And those are my answers. So now here you can see that I have done the same thing for the sine, cosine, and tangent of B. So if I'm looking at angle B, 4 is the opposite side and 3 is the adjacent side. So when I do the sine of B, I end up with 4 over 5 and so forth. So these are all filled in using those same definitions, and I want you to notice something here because I have some numbers that are showing up in both columns. So it looks like the sine of A is the same as the cosine of B. And 4/5 is showing up in both of these places. So it looks like the cosine of A is the same as the sine of B. I see a couple other relationships down here. I see a 5/4, so that means the cosecant of one is the same as the secant of the other. And here's a 5/3. So the cosecant here is the same as the secant here. So I've got that written over here. The sine of one angle is the same as the cosine of the other, and same with secant and cosecant. And that's because what used to be the adjacent side for one becomes the opposite. So adjacent 4 is adjacent for angle A, but it's opposite for angle B. So these ratios are going to show up in more than one place. So sometimes that's handy to know. So in a right triangle, looking at the 2 acute angles, the sine of one will be the same as the cosine of the other, and their secants and cosecants will also be the same. There's one other thing that I want to point out, and that is the measure of angle A plus the measure of angle B plus the measure of angle C is 180 degrees. For any triangle, that's going to be the case. Now, because this is a right triangle, it's 90 degrees, which means the other two have to add up to 90 degrees. Because this is 90, and those two have to add to 90 so that I get 180. And when you have two angles that add up to 90 degrees, we call those complementary. So here it says the sine and the cosine of any complementary angles are equal. That's what we saw in the last example. And the secant and the cosecant of complementary angles are equal. And same with tangent and cotangent, which simply means without a triangle, if I'm looking at the sine of 60, it must equal the cosine of 30. Or if I have the secant of 40 degrees, that must equal the cosecant of 50 degrees. it will always have that relationship as long as these two angles add up to 90 and these add up to 90. They're called complementary, and they have that relationship. Okay, let's do one of these problems now that has an irrational answer. So same Pythagorean comes into play here. Leg squared plus leg squared equals hypotenuse squared. So I get 25 plus 4 equals c squared, which means c squared equals 29, and c would equal the square root of 29. So I would write c equals the square root of 29 up here on the hypotenuse. And now let's find some of those trig values again. This time we're just asked to find the sine, cosine, and tangent. So I'm going to start with angle A. Here's angle A, here's the side opposite, here's the hypotenuse. So when I write it down, I would write 2 over radical 29. However, you can't leave that in that form because we have to rationalize the denominator by multiplying by radical 29 over radical 29. And so I'm going to get 2 radical 29 over 29. Now, just kind of as a side note, what if I had asked you for the cosecant of A? Now we know that the cosecant is what we get when we just flip the sign. So what I want to point out is it's easier if you flip it here instead of flip it here, and let me show you why. So I can either write it as 29 over 2 radical 29, and that's if I flip this guy. Or I could back up and flip this guy, and then it would be radical 29 over 2. Do you see how in the second one it's already rationalized? But if I use this one, the one that I had rationalized, I have to rationalize all over again. So if you're asked for the cosecant and you have a radical here, use this one to flip instead of your final answer. Okay, so let's take a look at what all of those give us. I move that away. You can see that I have 2 radical 29 over 29. Now, for angle A, here's my adjacent, here's my hypotenuse, adjacent over hypotenuse. You must rationalize, and that gives us this answer. And for tangent, it's just opposite over adjacent. Now for this column, I showed all of the calculations again, but remember we talked about how these are the same and these are the same because the sine of one is the same as the cosine of the other. So if you remember that, you could just take this and put it down for the cosine of B without having to go through this process. But it's not a big deal. You're just learning, so it's not a big deal to do the whole process here. And the other thing that we had talked about is that cotangent and tangent are reciprocals. So this is the one that you have to flip. So all of those things together, because this is so new, might be a little confusing. So it might just be easier to do all of your calculations by definition and then rationalize where you need to. Okay, let's move on. When we take units of measure, like example, we take a yard and we can divide that into 3 feet, and each of those 3 feet is equal to 12 inches. Well, the way that it works for degrees is that we take a degree, a single degree, and we divide it into 60 pieces, call them minutes, and we divide those minutes into 60 pieces called seconds. Now it might be helpful for you to think about what is already familiar. We know that we have hours divided into minutes, divided into seconds, and the math is the same. So 1 hour is 60 minutes, and each minute is 60 seconds. So any place you see a degree, you can think in your head hours. So in this case, 1 degree is 60 minutes, just like 1 hour is 60 minutes. 1 minute is 60 seconds, whether you're talking time or angle measure. That also means that 1 minute is 1/60th of an hour, or 1 minute is 1/60th of a degree, and a second is a 60th of a minute, or a 60th of a 60th of a degree. So 1 second is 1/3600th of a degree. So let's see where that comes into play. Here's an example of an angle that's written in degrees, minutes, and seconds. And sometimes we call that DMS, for degrees, minutes, and seconds. The 34 degrees, that's familiar. This is a little new. So sometimes we want it in this format, which is DMS, and sometimes we want it in decimal format, where this is a fraction of a degree. And the way that you change from this format to this format is to take the minutes and put them over 60, and take the seconds and put them over 360. And you can run that in a single calculation in your calculator. You can type in 34 plus 15 divided by 60 plus 30 divided by 3600, and you will get this answer, because your calculator knows that it needs to do the division before it does the addition, because it will also follow the order of operations that we've all been using for many years. I want to show you how to change degrees, minutes, and seconds into decimal degrees on your calculator. All you need to do is type in the degrees, plus, then put your minutes and divide them by 60, plus 46, which is our seconds, divided by 3600, and hit enter, and you get this answer. You don't even need to put parentheses, because your calculator knows that by the order of operations it should do the division of the fractions before it adds them together. So here are 2 example problems. It'd be great if you could just pause the video and run them on your calculator and see if you get this answer. I'm going to write down what the equation formula looks like. I've got 68 plus, I take my minutes over 60 plus my seconds over 3600, and I put them into my calculator, and I get 68.3794 degrees. For the next one, I would take 43 plus 21 over 60 plus 13 over 3600, and that gives me 43.3536 degrees. Going the other way, from decimal degrees to degrees, minutes, and seconds is a little more involved. Before we jump into the problem, I want to look at an example with time on a clock. So if I have 0.25 hours and I want to know how many minutes that is, well, 0.25, that's 1/4 of an hour, and we all know that 1/4 of an hour is 15 minutes. Well, where does that 15 come from if you're doing a calculation? And the answer is we change hours into minutes by multiplying by 60. If I've got 1/2 of an hour, 1/2 of 60 is 30. If I've got 1/4 of an hour, 1/4 of 60 is 15, which is why we have a 15 here. So to change hours to minutes, we multiply by 60. And then to change minutes to seconds, we would multiply by 60 again. Okay, here's the process then for changing 8.875 into degrees, minutes, and seconds. The first thing you're going to do is write down the degrees. And then on your calculator, subtract off the degrees, and that leaves us with 0.875 degrees. Well, if we multiply that by 60, that will change it into minutes. If I multiply by 60, I get 52.5, and now I'm in minutes. Well, We're going to write the 52 minutes and then take the 0.5 minutes and multiply by 60 again, and that gives us 30, but now we're in seconds. So I've got 30 seconds. So my answer is 8 degrees, 52 minutes, 30 seconds. I want to show you on your calculator how to change decimal degrees to degrees, minutes, and seconds. So I've got two examples here. So the first one, what I'm going to do is type in 8.875. So it's showing on my calculator screen. I'm going to write down the degrees, 8, and then I'm going to subtract it off, minus 8. And I've got 0.875. I'm going to multiply by 60, and I get 52.5. I'm going to write 52 down, that's the integer part, that's the minutes. Then I'm going to subtract it off, minus 52 is 0.5. I'm going to multiply that by 60 again, and I get 30. So it's 30 seconds. So 8 degrees, 52 minutes, 30 seconds. All right, let's do another one. I'm going to clear that. I'm going to put in 56.674. You don't really need to put in the whole thing. I'm going to take the 56 off, but just to keep it consistent, I'll subtract the 56 off. So I've got my decimal part, and I'm going to take my decimal part, 674, and I'm going to multiply it by 60, so times 60, and that gives me 40.44, and I'm going to take just the integer part, and that's my minutes. And then I'm going to subtract that off, and I get 0.44. I'm going to multiply that by 60 again, so times 60, and I get 26.4, and I'm going to round that to 26 seconds. So 56 degrees, 40 minutes, 26 seconds. So if you have the angle measure showing on your calculator, write down the integer part and then subtract that off. Take that and multiply by 60. Write down the integer part again, subtract it off, multiply by 60 again to change it into seconds, and then round it if you need to. Now we also need to be able to evaluate trig functions for angles on our calculator. So I don't care what kind of calculator you have. It can be a graphing calculator or a regular calculator. But what's really important is most calculators have a degree mode and a radian mode, and sometimes they have a gradient mode, but for sure they have these two. You need to make sure that it's in degree mode, and then once it is, then you can find the trig function by doing one of two things. So I've got two examples here. If I just want the cosine of 15.3 degrees, on some calculators you will press the cosine button, then the angle, and then enter, and you'll get your answer. On other calculators you have to put the angle in first and then press the cosine button, and it will automatically give you the answer. So I want you to pause this video and check out your calculator to see which one of these is the way your calculator works. Now if you press cosine and it shows COS on your screen, then this is the way that your calculator works. And then if it is given in degrees and minutes, or maybe degrees, minutes, and seconds, you are going to have to do the same process, but for this one you press the sign button and it should put it on the word sign on your screen, and then in parentheses 24 plus 32 divided by 60 and hit enter. Otherwise, you're going to have to take 24 plus 32 divided by 60, hit your equal signs, that's important, and then hit your sign button, and that will give you your answer. So again, pause the video and make sure that you know which one of these is going to work with your calculator, and make sure you're getting these answers. Because depending on your calculator, you might have to enter the angle first and then press the trig button, or vice versa. Okay, I want to show you on two different calculators how to find the trig functions. The first thing you need to do if you're on a TI is go to the mode button, and down here degree should be highlighted, and it is. So I'm going to get out of there, and then I'm simply going to type cosine and then 15.3. This will work whether you close that parentheses or not. I'm going to go ahead and close it, enter, and there's my answer. For the next one, the sine of 24 degrees 30 minutes, I'm going to do the sine, and I'm going to put 24 plus 32 over 60, close my parentheses, and hit enter. And that's how it works on the type of calculator where you type the trig button first. Now let me pull my phone out here because it's a little bit different. It's similar to some other calculators you might see. Now down here, this is where it switches from radians to degrees. If I want it into degrees, I need to make sure I tap that so it's in degrees. And then I'm going to, instead of typing cosine first, I have to type in the angle, 15.3, and then hit the cosine button to get my answer. And for the second one, if I clear that, for the second one I need to take 24 plus 32 over 60, so divided by 60, hit equals, and then hit your sine button in order to get the correct answer. Now I've got a few other examples here for you to practice on. Enter in these measurements and make sure that you can get these answers. Now your calculator will also go the opposite way for you. For example, we know that the sine of 30 degrees is 0.5. So on your calculator, if you calculate the sine of 30 degrees, you get 0.5. But what if we knew that the sine equaled 0.5 and we wanted to know the angle that it came from? So what if this was a mystery? Now we know from up here that the answer is 30 degrees, but what if we didn't know what that angle was? And I wanted to know what angle has a sine equal to 0.5. Well, there's a process for that. On your calculator, you should see a button that looks like this. And it should be the second function, usually, of your sine button. To get that answer, you're going to hit your second button, then the sine button, then what the sine equals, which is 0.5, and then enter, and you're going to get the angle. So the sine button is what you do if you know the angle and you want the sine. This button, or this function, is what you do if you know the sine and you want the angle. I often call this my Jeopardy button because, like the game show of Jeopardy, you're given the answer and you have to come up with the question. So in this case, I'm told the sine of theta is 0.5. Well, 0.5 is the answer. What was the question? Where did that come from? And that's where this button comes into play. So on your calculator, I want you to practice with some of these. Now again, you need to know your calculator as before. Some of your calculators will require you to put this in and then do the second sine, like this. And some of them will ask you to do second sine and then put the number in. So try out both of those and see which one of them gives you 54.5 degrees. And then try it with the other trig functions as well to make sure you know how to get these answers. Okay, I want to show you how to use the inverse sine button. These are the three buttons for sine, cosine, and tangent. And if you can see it here in blue on my calculator, it has the inverse buttons. It has sine to the -1, cosine to the -1, and tangent to the -1. That's this button right here. So in order to use it, I have to use the second button here. So what I do is I type second sine, and then I type in the 0.8145, close my parentheses, hit enter, and there's my answer. Again, let's do the next one. I do second cosine, 0.9848, close the parentheses, hit enter, and I get my answer of 10.0. Okay, Okay, now let's look at a different type of calculator. Let's see, there we go. Alright, so I don't have another one here at home other than my phone, but it will demonstrate what we need to see. First of all, the radians and degrees are this button here. If there's nothing showing, we're in degrees, which is what we want. So in this scenario, I can't type the function first. I have to type in the 0.8145. Then I hit the second button, which is right here, and then I hit my sign button. See, notice on my phone anyway, it actually changes what that button reads, and I get the same answer. Now, on some calculators, like on my phone, it's locked in there. It's still sitting in the second function, so you could do another problem by just typing in 0.9848, and now we want our cosine, and that gives me my answer. On most calculators, it won't default to that, and it will go back to the standard mode, so you would have to type in 0.3125 second and then tangent to get your answer. Now that button on your calculator that looks like this represents the inverse function of sine, and we call that arc sine. It can either be written like this and pronounced arc sine, or inverse sine. Sometimes it's written like this. So what we say is that the arc sine of 0.8145 equals 54.5. In other words, if I reverse that, that means the sine of 54.5 degrees equals 0.8145. So that's the relationship between sine and arc sine. For sine, you put in the angle, you get the sine. For arc sine, you put in the sine and you get the angle. And it can be written with either one of these notations. They mean the same thing. This is the one you're going to see on your calculator, but it will be referred to as either one of these. They both mean what angle has the sine of x. So when I read this, arc sine of 0.8145, I'm saying what angle has the sine 0.8145? What angle has the sine of 0.8145? And the answer for both of those questions is 54.5. And then the last thing I wanted to just mention is that when you have inverse functions, they undo each other, which means arc sine of the sine, those two functions undo each other and I get x. Or I can take the sine of the arc sine, they undo each other and I get x. So when we're talking about inverse functions, that would be like saying if I add 3 and subtract 3, if I square and square root, if I multiply and divide, if I find the sine and then the arc sine, they undo each other. They're operations that undo each other. So you'll be running into that as we get into the next section of solving right triangles.